Hello students, so today in this video we are going to do exercise 9.3 from chapter number 9, and in the one question it is given two concentric circles are there. Concentric circles are circles that have the same center. The radius of the outer circle is 5 centimeter. It means the radius of the bigger circle C2 is given to us 5 centimeter, or we can say that OA is 5 centimeter, and the chord AC of length 8 centimeter is a tangent to the inner circle. So there is a chord AC, and the length of the chord is given 8 centimeter, which is also tangent to the smaller circle C1, and we have to find the radius of the inner circle. It means we have to find the length of the OD. So now if we observe the smaller circle in which an OC is AC is a tangent to the smaller circle, and D is the point of contact, and OD is the radius, so it means angle ADC. Yes, angle ADC will be equal to 90 degrees. Why it is 90 degrees? Because AC is a tangent. Tangent makes an angle of 90 degrees at the point of contact from the radius. So now ADC is 90 degree. Now it means triangle OAD is right angle triangle. So in right angle triangle OAD, okay, before that we have to find the length of AD, right? So now if we observe the bigger circle, in the bigger circle AC is the chord, the same AC is the chord, and just now we have proved that angle ADC is 90 degrees. So if we from the center, if we draw a perpendicular on the chord, that will also bisect the chord. So it means AD will be equal to AD will be equal to DC, right? So it means the AD and DC will be half of 8 centimeter, that is they both are 4 centimeter. Now coming to here, in triangle OAD we will use Pythagoras theorem here. So OA square will be equal to OD square plus AD square. So from here we can find OD. So let's plug in the values now. So 5 square is equal to OD is given, we have to find OD, and AD is 4. So it means OD will be equal to square root of 25 minus 16. So it means OD is 3 centimeter. Now in question number 2, two tangents are there, PQ and PR, and they are drawn from an external point to a circle with center O. So P is the external point from which two tangents are drawn to the circle, PR and PQ, and O is the center of the circle. We have to prove that their quadrilateral QORP is a cyclic quadrilateral. So let's first understand what is cyclic quadrilateral. So a quadrilateral in which the opposite angles are, the sum of the opposite angle is 180 degree, is called quadrilateral, is called cyclic quadrilateral. So here if we prove that if we prove that the sum of the angle ORQ, not ORQ, ORP and OQP, ORP and OQP is 180 degree, and also the measure of the angle ROQ and RPQ should be equal to 180. If the sum of the angles, opposite angle, is 180 degree, then that quadrilateral will be cyclic quadrilateral. Now as we know that QP or PQ is a tangent to a circle and Q is a point of contact, OQ is a radius, so it means the measure of the angle OQP will be equal to 90 degrees, right? Similarly, we can say that angle ORP is also 90 degrees. As PR is a tangent to the circle, so it means this angle and this angle is 90 degrees. So it means their sum should be equal to, if we add these two, it means angle OQP plus angle ORP should be equal to 180 degrees, right? Now in quadrilateral QORP, we have just proved that this angle, the sum of this angle and this angle is 180 degrees. So it means 180 plus the angle ROQ plus angle RPQ should be equal to, yes, 360, because the sum of all the four angles of a quadrilateral is 360 degrees. So it implies that angle ROQ plus angle RPQ will be equal to 180 degrees. Hence the sum of the opposite angles are 180 degrees. So this quadrilateral is cyclic quadrilateral. Now in question number 3, if from an external point B, B is an external point which of a circle with center O, and O is the center of the circle, BC and BD are two tangents drawn such that angle DBC, this angle is given to us 120 degrees, and we have to prove that BC plus BD will be equal to BO, or we can say that BO is twice of BC. Okay, now it is given that angle DBC is 120 degrees and BC and BD are tangents to a circle. Okay, so if angle DBC is 120 degrees and this this point B is joined to the center of the circle, and we know that this OB will bisect this angle DBC. So it means angle OBC will be equal to, since OB is the angle bisector, so angle OBC will be equal to angle OBD. That means they are half of angle 120 degree. So it means they both are 60 degrees. So it means this angle is 60 degrees. Now we know that the also angle BCO will be 90 degrees, because BC is a tangent to a circle and OC is a point of contact and OC is a radius. So this angle will be 90 degrees. So it means in right angle triangle BCO, now we will use a trigonometry to find this relation. So in triangle BCO, angle C is 90 degree, and this angle OBC is an acute angle, that is 60 degrees. So BC is the base here and OB is the hypotenuse here. Here we are using this angle as acute angle CBO. BC is the base and OB is the hypotenuse. So we will use BC over OB. It will be equal to, yes, it will be cos 30, cos 60. So now we'll just BC over OB, and what is the ratio of cos 60 degrees? Yes, it is 1/2. So it means OB will be equal to 2 times of BC. So we have proved this, OB is equal to 2 times of BC. We have proved this. Now we have to also prove this, BC plus BD is equal to OB. Now we know that BC and BD are tangent to a circle from say external point B. So it means we can say that BC will be equal to BD, right? BC and length of BC and BD are equal. So from this relation we can say that OB is equal to BC plus BD. Hence it is proved. Now in the next question, question number 4, we have to prove that center of the circle touching two intersecting lines lies on the angle bisector of angles formed by the tangents. So here two tangents are given, PR and PQ, from the external point P, and O is the center of the circle. We have to prove that this OP is bisecting this angle RPQ, or let's name this angle 1 and this is angle 2. We have to prove angle 1 is equal to angle 2, right? So now if we see in this triangle, in the triangle P R O and triangle P Q O, PO is equal to PO. These are common sides on both the triangle. OR is equal to OQ. They both are radius of the same circle. Angle ORP is equal to angle OQP. Why these are equal? Yes, both are 90 degrees. Both are right angles, so these are equal. So by RHS congruency, we can say that these two triangles are congruent. Hence by CPCT, we can say that angle 1 is equal to angle 2 by CPCT. Okay, now in question number 5, it is given in figure AB and CD are two common tangents to two circles of unequal radii. So there are two circles and the radius are different of both the circle, and but they have two common tangents AB and CD, and we have to prove that AB is equal to CD length. We have to prove AB is equal to CD. So what we will do, we will first extend these tangents. We will extend these tangents and they will, let's suppose they are meeting at this point, name it P, right? Now if you observe in the smaller circle, PB and PB and PD is tangent to a small circle and from the same external point P. So it means the PB is equal to PD because tangent drawn to a circle from same external point are equal. And now if you observe in the bigger circle, in this one, PA and PC are tangents to the same circle, bigger circle. It means PA is equal to PC, same reason. So let's name this as 1 and this is 2. And if we subtract equation 1 from 2, we get PA minus PB is equal to PC minus PD. So it means PA minus PB is AB and PC minus PD is CD. So it means AB is equal to CD. So it means that the length of these two tangents, common tangents, is equal. Hence it is proved. Hope you have understood it, and don't forget to share and like this video. Thank you.